for a typical microgrid. Here, the microgrid is referred to the campus of Indian Institute of Science at Bangalore, India. So the Indian Institute of Science, Bangalore, was established 110 years back, where we had a single metering system where for the entire institute we have a 66 kV substation, followed by we have 25 other substations which feed to the departments. So the metering was the revenue which we pay per month is around 3 crores Indian rupees, that is 4.34 lakhs US dollars. So we have no control because it's a very old institute. A lot of loads were being added, the phase balancing, the harmonic imbalances, several of these aspects were not addressed. So what we have tried to develop, this is a project again with the Indo-UK program, where we have tried to do some work. The same thing is being presented here. Professor Umanand is being my colleague at the institute. I work at the Interdisciplinary Center for Energy Research and also as electrical engineering. So both of us are the part of the power committee at the Indian Institute of Science, Bangalore. So the energy management system typically which we are looking is into the power consumption, monitoring, and how the planning could be done in future. So here the energy management, we all know, is an interdisciplinary area which requires concepts from various fields to make the system to function, adopting new monitoring and control mechanisms which are required for proper planning. We are also planning to use the solar PV installations integrated with the grid, solar thermal, and we are planning to go in for a batteryless grid integration, the grid failure detection, islanding of the institute campus, and studying about the load management, and also see the real-time monitoring and control, which involves wide area measurements, distributed, and also the remote controlled actuators using the power line communication, mainly for the monitoring and also for the supervisory control system. The main objectives of this present work is to develop a multi-model system towards the saving of energy and the reduction of cost. So this ultimately will reduce the carbon footprint at the personal and also the community level. So I would like to mention here the Indian Institute of Science campus consists of 400 acres of land where we have more than 60 departments. We have residential accommodation for the students, then we have a faculty and quarters, and apart from the several amenities at the campus. So it is to obtain the information by developing suitable or employing the suitable sensors for the power network and employ various methods particularly for energy harvesting. This is one of the important aspects. So energy network is planned to have a recursive architecture which helps in balancing the demand response, and also proper decisions could be made with distributed processing in a real time and obtain context based information for various analysis. So this is how the power info and communication network is being planned. As I mentioned, we have a master unit substation which is 66 kilovolts step down to 11. We have 2 units of 5 kVA transformers which are feeding to various locations of the department. From the main substations there are 25 other substations. These other substation 1 to 25. Each substation is again from 11 kV to 440 volts. So each substation feeds few to several departments at the campus. So here the information is being seen that the power flow as well as the information flow from each of the transformer or the feeder junctions, where we have put up a smart metering, we have a data logger. So the information flow is in a minute where it is being collected and later on analyzed. Further to the departments, further to the substation, we have the departments which are connected to this substation. So there also we have tried to put up the data loggers and try to collect the information. So as I mentioned, in Institute of Science, we are treating it as a microgrid which has an area of 400 acres of land. So here the campus is being steadily growing over the years. It is 110 years old institute. Presently, we use power around 8 megawatts, and the 10 megawatts being the maximum demand as on present. So it is envisaged that the Indian Institute of Science goes green by offloading some of the electrical load from the utilities. So we have planned to go in for the solar rooftop and also use other renewable energy sources to bring down the cost of the revenue which we are trying to face. So here the efforts in this direction is mainly to address the following, that is rooftop, audit of rooftop area. As I mentioned, we have several departments. It is very difficult to finally find out. So it was an exhaustive exercise which we had to carry out for all the 400 acres, and in particular for the rooftop, some of the departments which are going in for further construction, so we have not considered, and based on the audit, we have come to a conclusion that there could be more than 7 megawatts of power which could be generated using the solar rooftop. So apart from that, we can also go in for department wise energy audit. Then we have also done the life cycle costing analysis based on using the smart metering. So I will just come into the details of the smart metering, how we have been using it. So this is the typical Google map of the entire campus which shows, and these are the areas where we have gymkhana, the playground, and some of the open areas where we cannot put up the solar PV installation. These areas where it is being shown are the departments which are scattered. There are 60 departments. So here we have tried to find out the real estate where we can install the solar PV panels. So with the help of the program which we have written using the entire information which is available, we have got the 47,000 square feet which could be used for the solar PV installation. Taking into consideration the efficiency of the solar panels, we will be able to generate somewhere around 7.6 megawatts. The requirement of Indian Institute of Science is 8 megawatts power. So is there a possibility to offload? So this was the proposal which we came up, and we have tried to see the proposal is gone ahead. With this, we have tried to calculate using the various parameters for the PV sizing, then the life cycle costing, and we have tried to get some of the results out of this, where our per unit charge per kilowatt comes around 2.93 Indian rupees. Typically we are paying 3 times the cost to the utilities with the electricity supply. So this estimation was presented to the director, where he has given us the clearance. So presently we have installed more than 600 kilowatts of solar power in the campus at various locations. I would like to share a few things. So solar rooftop, as mentioned, this is again, we have 2 campuses presently. So the first project has been implemented at the Indian Institute of Science campus at Bangalore, which is considered as a microgrid for this energy management system. Basically consisting, as mentioned, it is a master unit substation consisting of 66/11 kV and other 25 substations with 11 kV and 440 volts. So substations acts as a nodal point for the master unit substation. We have also, for emergency purpose, diesel generator sets and rooftop solar units which we have estimated and also started installation. The further process is also there to go in for hybridization with the renewable energy. So these are few of the installation. This is the 66 kV substation yard. These are few of the installations which we have carried out at various locations on the campus, on the rooftop of few departments. These are the inverter systems which have been used to inject into the local grid. So many of the times what we are doing is the installation of the solar PV on the rooftop. So we try to see it is integrated to the grid here, locally it is being available, and the main power supply which is coming is being not used during the daytime. So this is how it is being done. These are few of the DG sets. In fact, DG sets we are using it for the emergency purposes. So we have tried to integrate the entire system and see how the load monitoring can be done for the entire campus. This is a project which has been implemented, and it's been working for last 6 months. So for this we have used the smart meterings. Again, many of us know why the smart meterings are being used. Here I would like to mention the smart meters have been procured from the market. The data logger and the software has been developed by us. So this is the information. So here mainly the smart meters are basically used to measure the power, measure the energy, phase and line voltages, power factor, phase imbalance, peak demands, then power down periods and harmonic distortions. Further to that, we have also have added some information like to get the weekly and monthly information about the performance of various locations and the departmental units. Then peak demand alerts in case wherever the power demand shoots up. So there will be an alert where we take proper precautions. Then we also have a fault alerts wherever the faults are being generated, the information is sent to the server where the immediately attention is being done. So complaints, and we have established a video wall to monitor the entire information at 2-3 junctions, so where the information flow and where the server is maintained and the data is being collected. So this is how smart metering has been used. This shows a typical smart energy management. Basically the input, you have a 3 phase from the distribution system where a CT or a PT is being used to the smart meter. Again, the smart meter mainly connects to the CT or PT in case of high tension or extra high tension connections. Then we have a switched mode power supply for the data logger. This is the data logger which we have developed along with the software. So this data logger mainly connects to the meter through a Modbus, and further the data logger will be giving the entire information, stored information to the server. This is again happens through the local area network or through the Wi-Fi, or in case some places where we are not able to reach both, we use a modem where we collect the data. So finally this is the application, various applications which we try to analyze and see the data is being suitably done. So what are the layers in this solution? It's mainly the acquisition where we do it through the smart metering and the data logger, analyze the data, and various applications. So this is very important, what type of applications we are using. As I mentioned in the beginning, we had only 1 meter. The substation knows how much is the cost and we used to pay. None of the departmental head or the chairs of the departmental knew how much energy consumption of the department, what to do and all, what were the phase imbalances. So several of these things we have tried to develop. Now every month for last 6 months we are sending to the head of the department or the chair of the department about the power consumption, about how much revenue the particular department is being used, and also the phase balance information, so that a suitable corrections has to be done. So here again the data loggers registers the information and transmits it to the data over the network to a server, and the server pre-processes the data and sequentially uses in the database. So this supervised analysis to look into the deviation and see wherever important decisions could be done. So the competency as mentioned, we have tried to see that various information could be obtained, like energy imported from various nodes, energy imported from various departments. Then again this is the voltage from the substation and trends of active power of various phases. Then as mentioned, this is one of the solar power which is being injected into the local grid. This gives the heat map or active power over a month at the substation level. So several of this information could be got, and this data is very, very important for us. So here you can see the monthly phase balance range by nodes. We have, I told you, more than 60 to 65 departments, where each department, the power consumption, how the phase balancing is being done. This data is very critical. It gives us information where we can make suitable correction, bring down the energy cost, and also bring down the energy charges. These are various departmental phase imbalances. This is one important aspect where every month I was mentioning you, for last 6 months we are trying to give the billing of the particular department and the previous 3 months billing along with the profile of the power, which chairman of the department or the head of the department tries to know what is the phase balance and how he has to be doing the corrections. So further to that, we have made a small team where the team goes to the department, requests the chair, and see how the phase balancing could be done depending upon the data for the last 6 months. So this has been started, and this is again one more information of entire institute power consumption, again how much is the revenue which is being done. There are few small issues somewhere in the metering section. Yes, we are trying to find out, because this was the first time which we have implemented, and 260 locations the smart meters have been put, 260 locations. There are few small issues which we have been addressing wherever there are issues. Conclusions: the main primary objective of our work is to see a multimodal system is developed towards the saving energy and cost, which is developed and is being used. Implementation of a typical microgrid consisting of multiple generations, solar PV and other things. Then smart energy management system is developed and implemented for the entire campus electrical network, consisting of 260 smart meters have been put, and the information is being gathered every minute. We have established a video wall, energy dashboard to monitor, analyze and control the locations. This acts as an eye to the entire campus management system. So this facility was inaugurated in August by the director of the Indian Institute of Science. This is a video wall where the entire information is available at the Department of Energy in the institute. So thank you. I would like to thank the Indian Institute of Science for giving us some grants, and also the Indo-UK UKCRI project, which is a part of this activity. So thank you.
I was just, so a very interesting talk. I was just wondering a couple of things. Can you help me? How much is 3 rupees in
I think Professor Rajshekhar will be able to help me. 3 rupees is
3 rupees is 68 rupees is $1.
Yeah, 70 rupees is $1.
So that's unbelievably cheap.
Yes.
Energy, right? Does that include grant financing? Or,
No, presently we have no grant financing, only for the rural community and agricultural people. They give some subsidized this thing, but where we are paying is 6 rupees 90 paisa from the electricity utilities. So if we go for solar PV, it will be 2.3 or 3 rupees. Yeah.
About 10 cents.
Yeah,
Little less than 10 cents.
and one, just a technical question. So I see that you have substation plus 66 and 11, and then you have other substations. Why did you choose to have 2 different, or how? What was the methodology?
Yeah, what we have is the incoming to the institute is a 66 kV, 66 kilovolts to 11 kV. From the 11 kV, the entire institute, as I mentioned, is a 400-acre campus. So from there we have to step down, and from that particular transformer 11 kV to 440, so each transformer is around 500 kilovolts. That transformer will feed to few departments, say 3, 4, 5. In that way we have 40 to 50 50 departments, where each transformer will take the load of that particular department. That's why we have various substations. These were added over a period of time. It was not planned at an instant, because the 110-year-old institute, initially several departments have been added, so we had to add the extra load. That is the reason we have a higher level at 66 kV by 11. The 11 kV to 440 is stepped. The 440 is being used. 440 volts or 230 volts is the voltage which is normally used for single phase is 230. 440 is the 3-phase voltage which we use in the country.
One quick question, and then you.
What is the breakdown between demand charge and kilowatt hour energy charge?
Energy charges from the utilities is 6 rupees 90 paisa in the present rate, at up to certain 1 lakh units. Above that, again they charge 7 rupees 80 paisa. So it goes above the slabs. There is a slab.
KW charge, demand charge?
Demand charge is in our case it is 10 megawatts for the entire campus. The maximum demand is 10 megawatts. Yes, it is a charge associated, where it is a fixed charge initially. When we increase the charges, there will be a penalty.
Great, thank you very much. All right.
Thank you.